Hello students, welcome back to this new session again. Here I am continuing the inverse Laplace transform problems, the same topic. But this time we'll be working for the Laplace transform by partial fractions as the name suggests on your screen. Okay, I hope you all very well have studied partial fractions right from your PUC first year. And also we have solved so many problems in my previous semesters also. So it's not going to be a big difficult thing for you to work for the inverse Laplace transform using partial fractions, okay? Let's work with some more problems on this topic and then move on, okay? Let's find, here is one problem for you, just one. So here is one problem for you, that is find the inverse Laplace transform of 2s square plus 5s minus 4 divided by s cube plus s square minus 2s, okay? But before going to the solution for this, I just want you to simplify the denominator part, okay? So that you can get simple brackets there, okay? Try to factorize this. So it can be s cube plus s square minus 2s can be written as, I can take s common from here, just see that, it is s square plus s minus 2 you are left with, is it not? Now this is nothing but what? If you factorize this, it will be s plus 2 into s minus 1, just see, s square plus 2s minus s plus s minus 2. So this is what you get, the simple factorization for the denominator. So let us substitute the denominator there. You have 2s square plus 5s minus 4 over s into s plus 2 into s minus 1. Is it not? Now by partial fractions, what do you mean by that? You first write, use some constant a, say a is a constant, a divided by the first denominator term, that is s, plus b divided by s plus 2, plus c divided by s minus 1. Now all you need to do is find the constants a, b and c. So for that we need to simplify this. So you will have 2s square plus 5s minus 4 is equal to a times, now what is the LCM for this complete combination? Obviously the LCM will be the same as what is written in the denominator here. Now for those who have not understood this, I hope this is clear to everyone, but for the next step I'll just ask you to accompany a with the term which is not present in the denominator. So s is complete denominator is s into s plus 2 into s minus 1, is it not? But with a only s is present. What is absent? S plus 2 and s minus 1. So write it, s plus 2 into s minus 1, plus with b there is only s plus 2. So what is missing? S and s minus 1. With c what is missing? S plus 1 is there, s minus 1 is there in the denominator with it, but there is no s and s plus 2. Write that, okay? So this is the simplified form. Now all you need to do is put the values for s as 1, minus 2 and 0, get the values for a, b, c. So firstly let us put s is equal to 0. When you put s is equal to 0, this becomes 0, this becomes 0. You will be left with what? And moreover, what is the left hand side here? When s is 0, this is 0, this is 0, you will have minus 4. Minus 4 equals 2 into minus 1, minus 2, minus 2a. Or a results in minus 4 divided by minus 2 or 2. You will get the value for a as 2. Similarly, when you put s is equal to 1, when you put s is equal to 1, this turns 0, this turns 0. But whereas here what happens? It is 2 times 1 square, it is 2, plus 5 into 1, it is 5. So 2 plus 5 is 7, 7 minus 4 is 3, the LHS becomes 3. Now this is turning 0, this is turning 0. When s equals 1, only this remains, c into 1 into 3, 1 plus 2, 3. 3 into 1, 3, 3c you will get, or c equals 1. This is one thing, okay? Now finally the next term, if you put s is equal to minus 2, if you put s is equal to minus 2, minus 2 whole square is plus 4 times 2, it's 8, 8 minus 10, because here you are having plus 5 into s, s is minus 2, so minus 2 into 5 becomes minus 10, so it will be 8 minus 10, minus 2 minus 2, minus 4, minus 6. LHS is taking the value minus 6. Okay. Now this is 0. This is 0. When you put S is minus 2 here, it is minus 2 times minus 2 into minus 2 minus 1, minus 3 into minus 2 plus 6, B. So B equals minus 1. B equals minus 1. I hope it is clear to all of you. You have got the values for A, B, C. Now let us substitute the values for A, B, C over here. So what do you get? 2s square plus 5s minus 4 over s into s plus 2 into s minus 1 is equals to A value is 2 divided by s, minus B value is 1, so minus 1 divided by s plus 2 you will get. C value is already 1, so s minus 1, something like this, 1 divided by s minus 1. Now let us take the L inverse of 2s square plus 5s minus 4 over s into s plus 2 into s minus 1 becomes what? L inverse of 2 by s minus 1 by s plus 2 plus 1 by s plus s minus 1, or L inverse of 2 by s is 2 only, minus L inverse of 1 divided by s plus 2 is e to power minus 2t, plus L inverse of 1 divided by s minus 1 is e to power t. This is the solution for this problem. I hope it is clear to all of you. Continue with one more problem of this type. Now let us solve this problem. Find the inverse Laplace transform of s square divided by s plus 1 square into s square plus 4. Okay. So to solve this, I'll just ask you to use the substitution. Just put s square is equal to t here. First simplify it by putting s square is equal to t. So what do you get? It becomes t divided by t plus 1 into t plus 4. Is it not? I'm just substituting s square as t. So you will have a divided by t plus 1. Again b divided by t plus 1 by resolving into partial fractions. Okay, resolve them. So t equals a into t plus 4 plus b into t plus 1. Now put t equals minus 1. So it will be minus 1 is equal to 3a, because minus 1 into 4 plus 4, it will be 3. 3 times a is equal to minus 1 you all have. So a equals minus 1 by 3. Similarly, put t is equal to minus 4. This time it will be minus 4 equals this 0, but this turns to be minus 4 plus 1, minus 3b. So b will be 4 by 3. B will be 4 by 3. Now once you get the values for a and b, let us substitute them. Therefore t divided by t plus 1 into t plus 4 becomes what? It will be minus 1 by 3 divided by t plus 1 plus 4 by 3 divided by t plus 4. Or this can be written, I just want to replace t as s square now. The reason behind this is, actually you can use the formula for resolving it in partial fraction. Directly this can be resolved to partial fractions. You can even use that part also. That is ax plus b divided by s square plus, because when there is square inside the bracket, you know the rule for that. Okay, that way also you can solve. Okay, but this becomes very easy. That's why I have chosen this. Okay, so here I can write it as minus 1 by 3 outside. It's constant, 1 divided by s square plus 1. Plus 4 by 3 again it is constant, 1 divided by s square plus 4. Just see this. Okay, it will be easy for you. Then L inverse of s square divided by s square plus 1 into s square plus 4 becomes what? Minus 1 by 3 outside, L inverse of the first term plus 4 by 3 outside, L inverse of the second term, because L inverse also satisfy the commutative law, the linearity property. not the commutative, sorry. Minus 1 by 3 sine t you will get, plus 4 by 3 sine 2t divided by t you will get. Okay, you can further simplify this, plus 2 by 3 sine 2t. This is the complete solution for this problem. Okay, I hope it is clear to all of you. You can easily solve this, or else if you want to use that basic way of solving, but there you need to work for 4 constants a, b, c, d, because you need to split it something like this. See here, this can also be split as, I'll just show you, it goes very lengthy, that is why I have not chosen that way to solve this. So it is, you can write it as a s plus b divided by the first bracket. This way also you can solve it. cs plus d divided by the second bracket. Okay. This way also you can solve it. But that time you need to work for a, b, c, d, all 4 constants. Okay. This way I can do it just because resolving it into partial fractions, it is okay. Okay. You will get a very lengthy expression and lengthy work to work. Okay. But here, with this simple substitution you will get it. And why I am doing this, because I know the L inverse of the 1 divided by square plus 1, and I also know what is L inverse of 1 divided by square plus 4. So easily I can use those directly here and solve it. Otherwise it goes very lengthy. Okay. So this is the way you're going to solve. Okay. Continue in my next session.